All right, so we're back again, and I'm going to go back to my kinetics slide here. And we'll go for about 10 minutes, and I'll ask for any questions that we might have, and then we'll end for the day. All right, so let's see. We were looking at rate laws. So the rate law is something that's going to tell us what that rate is equal to, regardless of whatever time it is, by allowing us to plug in the concentration. So you're going to see in the rate law brackets around whatever our chemical is. So A and B here represent our chemicals. So they might be ethene, they might be the ozone in our last equation, and they have brackets around them. The bracket means concentration, and as a general rule, we're referring to molarity for the concentration.
Go away.
Let's see. Okay. All right, so it's going to look something like this. Now, this is not every rate law. It's going to have the concentrations of the reactants, and there might be an exponent next to each of these. There might not be. And then it's going to have K. So K is our rate constant. Now, K is not something that you can determine by figuring things out yourself. It is something that it is determined experimentally. So I will show you how to calculate it from problems, but it's not something that, oh, I have to memorize what this rate constant is, or I have to be able to figure it out from what the chemical is. So for right now, just think of it as something that I'll give you, and then later on, I'll show you how we can calculate those things. Why did that go up? There we go. Okay, so K is the rate constant, A and B are the concentrations at any given time. So what we're going to be talking about is the order of the reactions. The order refers to the exponents. So 1 is the reaction order with respect to A. Now notice there isn't a 1 here, and that's because in chemistry 1s are invisible. So if we have a 1, we just generally don't write it. 2 is going to be the order with respect to B. So since the exponent is 2, then it's going to be that order. And then I've said here that 0 is the reaction order with respect to C. Well, we don't see C as part of the equation. So let's think for a minute about what happens when we raise something to the power of 0. What is the value of that? Get a few people to put into chat. What's the value of any number raised to 0? All right, so lots of people here are saying 1, and that's correct. So again, if I raise the power to 0 and I get a 1, 1s are invisible in chemistry, and so that means that I have something I don't have to write down. The overall reaction order is just adding these things up. So I just take all of the exponents off of my concentrations and just add them. So I have a 1 plus a 2 plus another 1. Are you in here, Abby? All right. So let's see, where was I? Got things popping up all over the place. Okay, here we go. If a reactant doesn't appear in the rate law, then its reaction order is 0. So this is what I was talking about with C. We could write C like this with the 0, but because that's going to be equal to 1, we just leave it off. And again, you can't look at the equation and figure out what these numbers are going to be. You have to determine it experimentally, or somebody has to determine it experimentally. So our lab in a couple of weeks on crystal violet, we're going to look at how you can determine it experimentally. Right now, we're going to use initial reaction rate data to determine what the order of the reaction is. So let's say we have a reaction between oxygen and nitrogen monoxide. And I'm going to move this down so I can see the rates. Okay. So we do two experiments. In the first experiment, I have 1.1 times 10 to the minus 2 molar oxygen and 1.3 times 10 to the minus 2 molar nitrogen monoxide. In the second experiment, I keep my nitrogen monoxide the same because I'm only allowed one independent variable, and I double my oxygen. So this is doubling, this is staying the same. And we know that when we change the concentration or increase the concentration, then we should increase the rate, and that's what we see. And if we divide these two, what we're going to see is that this also doubles. So 3.2 times 2 is going to be 6.4. So what does that tell us about the order? We're going to look at the ratio of the concentrations. And so if I go back here, the ratio of the concentrations is these two concentrations, and I'm going to put the bigger one on top. So the ratio of the concentrations is concentration 2 over concentration 1, and we said that it doubled, so that ratio is 2. And we look at the ratio of the rates, and we said that doubled, so that rate is 2. So the ratio of the rates, the second thing we calculated, is going to be equal to the ratio of the concentrations raised to our exponent, n. Well, if they're equal to one another, then n must be 1. So if the ratios are equal, the order is 1. And so what we can tell then is that the order with respect to oxygen is 1. So in our rate law, we would have brackets around oxygen, and then we wouldn't write the 1, but it would be raised to the exponent of 1. Okay, so the idea is if what happened to our reactant is the same thing that happened to the rate, this doubled and this doubled, or this tripled and this tripled, this is times 1.78, this is times 1.78. If they are the same thing, then our order is 1. So let's look at the nitrogen monoxide here. So we have 5 different reactions here, but I'm just going to look at the ones where the oxygen stays the same. So I'm going to blank those out to kind of focus us. So oxygen is staying the same here. The nitrogen monoxide is changing. So here, the nitrogen monoxide is doubled. What happens to the rate? Take a look at that and see if you can figure out how many times it has increased. So this is about 4 times as much here. So they're not doing the same thing. This is doubled. This is 4 times as much. Now, if I look at 1 and 3, this is 3 times as much. 1.3 to 3.9 is 3 times as much. This, going from 3.2 to 28.8, is about 9 times as much. So let's plug that into the equation that we had. The ratio of the concentrations for the first one was doubled, so that's going to be 2. The ratio of the rates was 4. Okay, so using this formula, 4 is equal to the n. So what would n be? Plug that into your chat window. All right, that's looking good. Exactly. 2 squared is going to be equal to 4. Now, theoretically, I should get the same thing no matter which data set I choose. So let's take a look at the other data set. If I have, I'm going to move my screen out of the way. If I have 9 as the ratio of the reaction rates, then that is going to be equal to 3 to the n. So 3 to the second power is also 9. So regardless of which set we get, we end up with an order of 2. So that's how you would experimentally determine the reaction order. Okay, so what you should be able to do at this point is you should be able to look at a rate law and tell me what the order of the reaction is with respect to each chemical and what the total order is. And then we'll practice on Friday doing some more of this, looking at the initial reaction rates. Are there any questions about any of the content we went over today or anything else related to the class? Feel free to plug those into your chat window or unmute yourself and ask a question. All right, well, I'm not seeing anything. I'll turn off my video and I'll leave this on if you guys want to chat with each other for a second, and then I will turn this off once everybody has left the room. So feel free to chat with each other.